Good morning, class 11th. So, this session is going to be for chapter number 1, physical world for class 11th. So, students, we are going to study about that what is physics, what are the basic principles of physics, and what is the use of physics, what is the excitement of physics, what is the scientific requirement of physics, and why we study physics. So there are so many questions in our mind that why this is included in our syllabus. Okay, so everything will be answered by me in this particular chapter. So this is a very interesting chapter, little theoretical one, but yes, this is required so that you will become motivated to study physics with full of energy. So the very first question which arises in our mind is that what is physics? How to define physics? So students, physics is derived from a Greek word, and that Greek word is fuses. Okay, and the meaning of this Greek word fuses is nature. So obviously, the study of nature is known as physics. How to define physics? It's a vast syllabus we are talking about. Every physical phenomena we observe, either that is rainbow is formation of rainbow, and either we are studying that how the water is boiled, either we are studying that how even I am using this technology, this all is because of physics. I am using electricity. We are using all the digital framework. We are using everything. So many places we are using the physics. Okay. So life couldn't be this much easier if physics wasn't there. So this is all about physics. So it's the study of nature. For example, we study about motion, we study about gravitation, we study about electrodynamics, we study about magnetism, we study about thermodynamics. So all this is included in physics. So, and this is the part of nature. So we can say study of nature is known as physics. Students, while we are studying physics, so there are two principal thrusts. There are requirements in physics while studying physics or while developing physics. So what are these requirements? One is unification. So the meaning of unification is diverse physical phenomena in terms of few concepts. We are discussing about law of conservation of momentum. So that law of conservation of momentum is not only applicable between two objects or between two cars. So this law of conservation of momentum can define so many other laws. So that is known as unification. So diverse physical phenomena means so many physical phenomena can be explained by using a single law, and that law is now unified. So unification means we can derive so many physical laws by using just a single law. That is known as unification. For example, I have taken law of gravitation. You already have studied law of gravitation, that if there are two masses, both the masses will be attracted towards each other. Okay, and Newton defined it that how much it will be attracted. So suppose there are two masses m1 and m2 separated by distance r, then F is equal to g m1 m2 upon r square. So the force will be. So that law of gravitation is not only applicable in one fact, it is applicable in so many facts. For example, apple falling. One apple has been fallen in earth, the reason is law of gravitation. So it defines apple falling. It defines moon revolving. Why a satellite revolves? Okay, the reason is law of gravitation. How? Because we already know, suppose there is a mass and along it one mass is revolving. So for revolving, it requires centripetal force. For moving in a circular orbit, any object requires centripetal force. Then from where that satellite is getting the centripetal force? So from where the moon is revolving around the earth, the answer is that force, gravitation force between earth and the moon is providing a centripetal force. So moon revolving can be explained by using law of gravitation. Apple falling can be explained. Pendulum swinging. The swinging of pendulum is also the example of force of gravitation, law of gravitation. So it defines three physical phenomena is defined by using one law. So that is known as unification. We can take so many more examples. For example, law of conservation of energy. We already have studied in physics in our earlier classes that energy can neither be created nor be destroyed. it can be converted from one form to another. So that is known as law of conservation of energy. This is used in Lenz's law. What is Lenz's law? In class 10th you have studied. In an electric circuit, the direction of the induced electric current will be such a way that it will oppose the fact by which it is generated. तो हमेशा किसी भी इलेक्ट्रिक सर्किट में जो करंट की डायरेक्शन होगी वो उसी रीजन को अपोज करेगी जिससे वो खुद जनरेट होगी. Why it is there? Because it is because of the flux should be conserved. And flux is what? Flux is the rate of change of phi is equal to magnetism. So the number of field lines are suppose changing. It means so that the magnetic field is changing, the energy is changing, and there should not be any change in energy. So Lenz's law is also using law of conservation of energy, principle of calorimetry. This you will study in class 11. Okay. Kirchhoff's second law. This also you will study in class 12. So you will come to know that whenever we are using any law that is defined by only law of conservation of energy, so many laws can be defined by using one law. That is known as unification. We can take so many examples, okay, but currently I have taken two examples to explain you unification. Means by using one single law, you can explain various laws or various physical phenomena. Now, students, while studying physics, the another thrust is reductionism. What is the meaning of this? Attempting to derive properties of complex system by small parts. That is microscopic level, macroscopic level, you will come to know. For example, suppose we have a law and that defines for a very small level. So that small level is known as macroscopic level. It is only applicable to small particles. So what we do, we combine these laws and we try to define it for a complex system, for a more complex system. We solve it part by part and try to solve it, and that is known as reductionism. By the word it is clear, reduction. We are reducing it, and for reduced, we have the law, and we want to just integrate it, and we want to create a new law for a complex system. That is known as reductionism. Okay, so this is about firstly we study for macroscopic level, and then we define it for molecular level. Now, students, scope of physics. We are studying physics, then scope and excitement of physics. So, students, in macroscopic domain, we study physics not only in macroscopic domain or microscopic domain, or for a complex system or for a simple system. We study physics throughout the nature. And in classical physics, few elements are added. So that elements are thermodynamics, electrodynamics, and optics. What is thermodynamics? In classical physics, these parts are added. In classical physics, most of the concepts of classical physics were defined on the year 1900. So the first is thermodynamics. This is the study of heat, temperature, system, surrounding. This is what we are going to study. The, the exchange of heat between the system and the surrounding will be studied in thermodynamics. Okay. In electrodynamics, what is the meaning of electrodynamics? Students, there are three words. One is electrostatics. The meaning of electro is charge. Okay. Statics means at rest. So when charge is at rest, that is added in a part of physics, electrostatics. Then we study electricity or current electricity. Here we study that the charge is in motion. Okay, current can be generated when charge is in motion. Current electricity. Then we study magnetism. Here we study that charge can acquire the acceleration. Now the charge is moving and accelerating also. In electrodynamics, same, the charge is moving and the charge is accelerating as well. So when the charge is accelerating, this comes under electrodynamics. So we study about that what will be the behavior of charge when it is accelerating. This we will study in class 12. Thermodynamics we will study in class 11. Optics. Currently, you have studied this in class 10th. Okay, you have studied light chapter, and that is included in optics. So, study of light. the phenomena related to light is known as optics. So this was few things related to physics, and in the upcoming lecture we will study further about physics. Thank you. God bless. So students, now we will study that how physics helps other branch of science for technology. So students, the very first point, we want to correlate that how physics is related with the other branch of science. So the very first relation I am going to explain you for physics in relation to chemistry. In chemistry, we study ionic bonds, bonds, compounds. So for formation of compound, for formation of bonds, it was required to study the structure of atom. And the structure of atom was studied with the help of physics. So physics helped the chemists to develop their structure of atoms or to develop their theories related to chemistry. Even X-ray. X-ray was very important weapon we can say for developing out chemistry tools. Okay, so X-ray could be used for further studying chemistry. So we are actually helping the chemist for developing out their theories related to their branch of science. So physics is helping chemistry by developing the structure of atom, by developing X-ray theory. Okay, now students, we are going to study about physics in relation to biological sciences. That how we are helping bio. So in microscopic level and X-ray. X-ray is a very important tool, and we can microscope is there. Okay, by using the microscope, the bio one can study about their structure of plants, their structure of animals, and further they can magnify it and they can get the clear picture of it. So we are helping them. Physics in relation to astronomy. In astrological science, we are helping. How we are helping? Theory in physics often use mathematical concept, that is for physics in relation to mathematics, astronomical telescope and radio telescope. So for astronomy, that is required. If you want to study about stars, you want to study about moon, what is required to you? Astronomical telescope. So that you can further magnify it and you can see clearly what is the actual picture of it. Radio telescope, that is also helping. So firstly, let me tell you, physics is developing the tools for other sciences. Even we are helping in medical field as well. All the equipment, all the tools are made by using the physics laws. So we are more connected with all the technologies by using physics. Physics in relation to mathematics. So it's one thing which I want to make you clear. What I understand that maths is not a subject. It's a language of physics. We study maths just to understand physics. So even we started with mathematical tools in the beginning. Why we started? Because it was required to understand the physics laws and to apply it in mathematical way. So yes, we can say that maths is actually helping us to study physics. Okay, so this is what I have written, elaborated. Theory in physics often use mathematical concepts. We have derived any theory, but we require the mathematical proof, so we are using maths. And I already have told you that why we are studying maths, just to understand physics. Now, physics in relation to society. We are helping the society. Simply, we are helping out the society. How we are helping out the society? By development of telephone, telegraph, all the technology tools we are providing them. We are providing them radio, television. Okay. Now, weather forecast is very easy for us by using satellites. So, satellites we have launched just to get the weather forecast and to convey out a message by radar system, radio detection and ranging. Electronics, computers, we are using the technology, internet. So everywhere we are helping out society by using the physical tools. Physics in relation to technology. We can say that technology is the application of physics. We are developing a physical law, and by using that physical law, we are actually developing out the technology. So this can be used for further generation. I hope you understood this. So students, now we are going to study about fundamental forces in nature. There are four fundamental forces in nature. The very first one is gravitational force. Then we will study about weak nuclear force. Then we will study about electromagnetic forces. And in the last, we will study about strong nuclear forces. So, what is gravitational forces? We have studied it. The force which is acting due to mass of the object is known as gravitational force. The forces which are developed due to masses of the object is known as gravitational force. Suppose there is one object, say mass m1, and another object mass m2, and the distance between the two masses is r. Then what is the force of gravitation between these two masses? F is equal to g m1 m2 upon r square. And who gave this law? This law was given by Newton. This is known as Newton's gravitational law, where g is a constant known as gravitational constant. What is the value of gravitational constant? Value is 6.67 into 10 power minus 11 Newton meter square kg minus 2. Why this is Newton meter square kg minus 2? You can see clearly g is here, and when we will calculate the value of g will be fr square upon m1 m2. Now substitute the values of the units. Force is in Newton meter square upon kg square, so kg minus 2. So this is gravitational constant. So, students, gravitational forces are the weakest forces in nature. I will prove it. Firstly, study weak nuclear forces. In the last, I will tell that why these are the weakest force in nature. Weak nuclear forces. So, how these weak nuclear forces are developed? We have to study this. So, these were developed during the study of beta decay. What is beta decay? So, the process when one neutron when a neutron is further broken out, then that neutron is converted into one proton and one electron. And when this neutron will be converted into proton and electron, energy will be released and forces will be developed, and that forces are weak nuclear forces. Okay, the weak nuclear forces are the forces of interaction between the elementary particles of short lifetime. So these forces are developed for a very small duration. When this beta decay will held out, then for a small instant, these forces will develop and will vanish out later. Now, students, the third force which we are about to study is electromagnetic forces. So these are forces between charged particles. How these forces are developed? Let us study this. Suppose we have a charge Q1, we have another charge Q2, and these two charges are separated by distance r. Then according to Coulomb's law, F is equal to k Q1 Q2 upon r square, where Q1 and Q2 is the product of charges. So we can understand this. If the value of charges will be greater, then the force between these two charges will be greater, and F is inversely proportional to r square. So this follow inverse square rule. Electromagnetic forces, I have categorized friction as the electromagnetic forces. You will further study in the friction force is also a kind of electromagnetic force. Suppose we have a green board and we have a piece of chalk and we just keep it there on the green board, that will be stick to it. Or why I have written all these things are visible to you. Why these are not getting out? Or why the things which were write by chalk are there? Because there is a force of friction between the layer of that board and the chalk. In the similar way, friction is included as electromagnetic force because this work because of the charged particles. Okay, you will further study in deep in your higher classes. Up to class 11th and 12th, you will study only up to this much extent. Now, I said that gravitational forces are the weakest force in nature. Why? So I can give you one example. Suppose, have you remember one example you have studied in your previous classes? That suppose we have piece of papers and we have a comb, okay, and that comb we are just charging it by the dry air, and when we are bringing it near to the piece of paper, the piece of paper are attracted towards it. What it shows? It shows that even gravitational force was working on the piece of paper. Still, the papers are coming out. Gravitational force was working downward, and we are bringing the electrostatic force, and the piece of paper are attracted towards it. So, which force effect is greater? The effect of electrostatic force is greater than gravitational force. So, gravitational force are weakest force in nature. Now, students, we are about to study strong nuclear forces. What are these strong nuclear forces? The forces that binds the neutrons and protons together in a nucleus. We have studied that inside the nucleus there are protons and the neutrons. And which force is actually binding them? That is strong nuclear force. And that is why if you want to break it, you require a very high amount of energy. And that is known as binding energy. Okay. Now these strong nuclear forces are this much greater. These are 10 power 38 times greater than gravitational force. 10 power 38 times. It's a very high figure. Now these forces are very shortest range, means 10 power minus 14 meter. Obviously they are working inside the structure of atom, so these are considered to be a very small short range forces. They don't obey the inverse square rule. The force, most of the forces are inversely proportional to the distance square, but these forces do not obey that rule. Now, these are non-conservative. Non-conservative means these forces do not depend on path. Okay, path will not affect, no longer affect such kind of forces. I hope you understood this. Thank you. God bless. So now students, we are going to study about nature of physical laws. So we are going to study about the first one is law of conservation of energy. You have studied this in your junior classes. That is, that energy can neither be created nor be destroyed. It can only be converted from one form to another form. That is known as law of conservation of energy. Then we study law of conservation of linear momentum. If you remember that we have already have solved it in our junior classes. Okay, if you have forgotten, then I can solve it. What is momentum? Momentum is the product of mass and velocity. So momentum of a body is represented by P. P is equal to m into v. So law of conservation of linear momentum we have proved in our junior classes. If you remember, suppose there is a mass m1 and there is a mass m2, it is moving with velocity u1, and another mass is moving with velocity u2, and suppose they both collide. And because of collision, after collision, the velocity of mass m1 will become v1, and velocity of mass m2 will become v2. So, according to law of conservation of linear momentum, m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2. So, this says that total momentum after collision and total momentum before collision are no longer going to be dissimilar. Both will be same value. Now, students, the third one is law of conservation of angular momentum. What is angular momentum? So, the total external torque acting on a system is zero if angular momentum of system remains constant. If we are not changing the momentum of this body angularly, okay, there is no change in angular momentum, the total external torque will be zero. What is torque? Actually, the difference between torque and force. There is a difference between torque and force. Force in our body always give result to linear motion. Okay, and torque is always giving angular motion. Okay, so when torque is zero, then angular motion is possible? No. And if angular motion is not possible, then angular momentum will be zero. Okay, so this is the law of conservation of angular momentum. Now, D part is law of conservation of charge. In a system, the total charge is always conserved. For example, suppose I have 5 electrons, okay, and these 5 electrons, 3 electrons I have given, and 2 electrons somewhere else. Then, what is the total charge of the system? Still 5 electrons. So, charge is always conserved. Charge can be transferred from one body to another body, but the charge of whole the system is always a constant. For example, we have NaCl, okay, the total charge is 0. Now, suppose this is further broken down, Na plus Cl. What is the charge here? Plus 1 electron. What is the charge here? Minus 1 electron. What is the net charge? 0. So, the total charge of a system is always conserved. That is known as law of conservation of charge. So, these are the four laws of the nature of physical laws. I hope you understood this. Thank you. God bless.